Hello, everyone. Thank you for still having passion and joining afternoon session. Today, I would like to share my work of research, evaluation the carbon neutrality of concrete recycling using CO2 capture technology from cement production. So a bunch of fancy words here, and let me just emphasize some specific things, what we are going to focus on. So first of all, we're going to talk about the concrete recycling and how to improve the property of recycled concrete. We're going to use carbonization technology, and from where we're going to take CO2 emission is going to be cement plant. Let me just give a bit background because it's going to be Hong Kong case study or Asia overall. So Asia used a lot of concrete, and of course we have a lot of concrete waste constitute a major portion of construction and demolition waste generated by construction industry. During the demolition of building, we have concrete rubble, which is come to the recycling facility, and further crushing and recycling process, we can get high quality recycling aggregate, which can be moved back to the construction. We have to, high quality concrete recycling aggregates can be moved back to the construction site as an aggregate for new concrete, fill material for embankment construction, fill material for land reclamation. So to give you some more statistics about how big the problem, the construction industry in Hong Kong annually uses about 17 million tons for aggregates. The majority of this, approximately 88%, is utilized as aggregate in concrete production. But actually, more than 2 million tons can be obtained or can be used from the recycled concrete aggregate. So also when we do recycling and crushing concrete rubble, during this crushing process, we can have like waste concrete powder or waste cement. It's different terminology. And these byproducts made up about like 30–70% of concrete used, and depend on how small we want to obtain a recycled concrete aggregate. And it, in countries like in China, the annual production of waste concrete powder for the recycling process can reach enormous 60 million tons. So, and if you see the process, traditionally, the waste concrete powder just ended up in landfill. And what we try to do, we're trying to think like how we can bring WCP back to the cycle. So some solutions can be proposed when we use like carbonization technology to strengthen the property of waste concrete powder. So then we can use it as substitute material instead of like cement on some natural materials. So carbonization is a process where the concrete absorbs carbon dioxide from the air over time, which can strengthen the material and reduce its carbon footprint. Some good cases already exist. First of all, the carbonization process can be done in laboratory. Usually they use commercial CO2, and good cases come from France when they use CO2 from the cement plant to do carbonization process. Let me just summarize the different problems and add some more points in this one. First of all, like we try to incorporate waste concrete powder into the concrete waste recycling cycle, reduce dependence of concrete waste carbonization on commercial CO2, which is quite popular when we are going to laboratory. And also
the biggest problem, like we try to think about how to reduce emission from concrete plant, because so far concrete plant contribute 8% of CO2 emission, like in a global perspective, and also minimize construction demolition waste and its native impact. So we formulate the study problem, like the study aims to assess the feasibility of recycling demolished concrete byproduct, waste concrete powder and recycled concrete aggregate, into aggregates substitute for use in concrete mixes by utilizing active carbonation method with flue gas from cement plants, an area which haven't been considered quite a lot in research. The research we started like to understand what is going right now at the process at recycling process currently. So we have construction site and demolished concrete come to the recycling facility and come to the concrete production. So to formulate the feasibility model, so we use activity-based costing approach. And the first we need to understand what is the parameter, and we assign different parameters according to the processes. And start to formulate model, which is all the materials we consider it as a flow. So in flow we have like concrete rubble, recycled aggregate, and WCP, CO2, cement, natural materials. And also through each facility, different materials like contain different resources. For example, we need to recycle concrete rubble, so we need energy, we use equipment. So how we just formulate, we can just propose the matrices where different flow on materials, and we assign what kind of resources we need to use according to each facility. So this matrix shows how much resources we need for 1 unit of material. We need the cost to understand like the cost and also the quantity. So and we can have the overall picture about this one. And the same things we do in terms of environmental cost. The same matrix, different materials flow. We assign how much capacity it's take to recycling them and assign the quantity a cost. And to apply our model, we use Hong Kong case study. Basically, we try to propose this for the government. We do this project for the government. So we take specific taekwondo sorting facility, which under the government. And we another facility around Hong Kong, who is the bigger player, and also try to assign what technology have to be added in which facility. The data was collected from government reports, Hong Kong standards, life cycle assessment tool databases, production specification for recycled concrete, and estimated annual amount for concrete rubble is more than 80,000 ton. We assume that 15% of recycled concrete come as a WCP, and also we calculate how much CO2 we need to carbonize all this amount. As a result, you can see, so here you see 3 graphs. Basically, we compare the environmental cost for the traditional process and for proposed process, and also we calculate how much cost would be to incorporate different technology. And basically, like this quite impressive, the orange graph, which shows the advantages of proposed approach due to capturing CO2 by carbonization process, and also due to CO2 collection from the cement plant, and conservation of natural materials, because if we use WCP, we need less cement, we need less sand. So, and quite small price in terms of integration technology, because it's not very expensive technology. Yeah, this is the result of. Come to the conclusion part. Active carbonation of WCP and recycled congregate using flue gases from cement production significantly reduce environmental cost. Alternative recycling methods show a 362% increase in efficiency for recycled concrete aggregate and WCP, while flue gas utilization results in a 440% improvement in cement processing. Enhanced processing of natural material leads to increased benefits, highlighting the importance of conserving resources and reducing energy, and also encourages government support for carbonization technology and outlines plan for future research on adapting the model to global markets and addressing logistical challenges. This is research grant, and this research is a part of research grant. Thank you very much